All right, welcome everyone. This was a bit of the advertisement of the day, but today we're here to talk about defense in depth and to talk about defense in depth and shift left to navigate compliance-heavy environments. It's a bit of the story of Crosslink and how did we tackle some challenges while bringing our value proposition to life and also not losing speed. So I drafted a small agenda. We're going to go through, in general, challenges of software development, how separation between the what and the how. It's a good idea to make the journey that we had in this non-functional abysm. So what were the challenges that we faced and how did we try to give it a structure to be able to embed them in our technology. Then I'm going to shift gears towards security. So one of these non-functional security is quite a big topic. And I will be focusing on two things. That is the shifting left of security and defense in depth as a framework of thought to understand security controls in the whole development life cycle, and as what I believe is a really good strategy to think about security. Then we will go to the takeaways. I think that there are mainly three that you can take home independently on which background you have, and then Q&A. So I will be more than happy to answer your questions at the end of the talk. I see that there is around 40 attendees, so Mariska will be helping me with the questions that may arise at the end. So we will try to have it written, and then if we don't understand something, we can just turn on the mics and clarify. All right, who do you have in front of you? I am Santiago Aragon. I'm very happy to be here. I'm tech lead of Crosslink. And well, my story begins actually far away from here. I am born and raised in Mexico City. And afterwards, I moved to Europe. I live in 7 cities. What brought me here well, was a combination of studies and work. In my, let's say, past, I was going towards an academic career, so I have, I think, several number of affiliations. I studied in a couple of universities in Europe. And then actually I decided to move to the industry, and I started a couple of things myself. And over 5 years ago, I joined ING, and over 3 years ago, I joined Crosslink. On my free time, what do? I'm actually preparing for a marathon this year. I do like CrossFit weightlifting. I love to learn new things and cook. And I have been lucky enough to have friends around innovation and entrepreneurship that consider me their advisor. So that's a bit about me. If you ask what is actually motivating me, is these 3 things: people, complexity, and technology, and the intersection of them. And that's a bit of what has drive my career and what passions me to what gives me basically the energy to solve challenges, and is one of the reasons why I am actually very happy in Crosslink. All right, but what do you have today? The challenges in software development. I'm going to start with the traditional metaphor of an iceberg, right? So this has been used in several topics, but today is going to be around software development. Whenever we think about an application, and it doesn't really matter how technical you are, you always think about how the application should do its work. So basically, what is the application actually doing? And I like to think about this as the top of the iceberg. So actually, when you say, I need a calendar app, right? So it sounds quite simple, that the function, the what is a calendar, maybe to schedule things, etc. But if you are into software development, or you have run a business in tech, or you have had to buy an application, you quickly start figuring out that there is a couple of other things around the application that you also need to solve: performance, availability, confidentiality of the data, especially if you are in Europe. GDPR is quite important. Integrity of the data, if you are in a regulated domain like banking or FI, financial institutions, we need to, for example, make sure that payments are actually not modified along their life cycle. And maybe, Mariska, can you help me to mute all the participants?
Yeah, I'm busy with it. Yeah.
Thank you. Scalability, completeness, timeliness, and the size of this iceberg actually depends on your line of business. So at the end, highly regulated environments tend to have a very, very big mass under the functional part. And if that was not enough, lately, and all my tech colleagues, fellow developers, and people that have tried to recruit in IT cannot let me lie, it's actually extremely hard to get engineering talent. But just to make it clear, this is not a talk about icebergs. It's a metaphor, and the top of the iceberg is the functional requirements. And to simplify it, we will just mention it as the what. So yes, it will be very nice to have a way to only care about the what. So and this is where Crosslink starts baking a couple of years ago, over 5 years ago, to rethink about how will it be if we only figure out the what, give it to someone that is an expert in a product. So, for example, customer journey expert in payments, a product manager in billing, and the rest, that is exactly what we saw under the water. All the non-functionals is managed automatically. So at the end, if how an application is secure doesn't really add to the functional part, and all the non-functional story adds tremendous amount of complexity that in a lot of times is complexity that is repeated over and over from project to project. Actually, the founder of Crosslink thought this could be done better, and that's where Crosslink comes in. So Crosslink provides next generation banking software as a service, and by abstracting these two layers from each other, so the what and the how, we try to help banks to innovate and replace legacy systems and implement new bank grade services faster. So actually, we propose a bit of a different way to develop software, and it's similar to the 3D printing process. So someone that is an expert in a product will come with an idea. We'll use this set of tooling that you have available when you want to print a product to design it. And the only thing that you do then is you upload the model to the 3D printer, and you have a printed object. So that is the bar that we try to reach regarding software development. So what we have developed is a set of technologies that allow us to consume the banking process in an unambiguous way. In this case, it's specifications in form of a domain-specific language, and that is basically a tool for the domain expert to express this product in terms that he or she understands. Then we feed this just as the model is fed into the 3D printer into our generators. And after this process is finished, we end up with a full stack application. And this idea is actually quite powerful because it abstracts what the application is actually doing from how the application is actually doing. And I will not go in detail into this, but you can think about all the consequences of this separation: technology change, compliance, reliability, security, speed to market. And basically we map this into 4 stages. That is the define, generate, run, and use. And each of these stages has a specific part of our technology attached to it. It is in the define part, the specification tools. Then we have the software generator that is the equivalent to this printing machine. And then you have the generated software running in a software platform, and that will be the last part of our solution. But how does that actually relate to the what and the how? Why are we intrinsically making the time shorter? So if you come from the software development background, you might have seen this before. So it basically talks about in a vertical, in the horizontal dimension about time, and how each of the phases of a software development implementation, or from the ideation to the implementation, is mapped to the testing part. What you can see, and this is a spoiler alert before what you will think about Agile, but at the end the message is going to be similar, that there is a distance in time from the user needs to the actual final handover from the working system, right? And that is basically going down this iceberg of non-functionals, and that's why this is very relevant, especially in the non-functional part, because those are very hard to test, or those are a lot of times ambiguous, and those also change based on external inputs like regulators, new technologies, etc. So to be very clear, that is how our iceberg will fit here. So the user needs and the user requirement will be the what. Everything else will be the how. How do we engineer the system? How do we architecture the system? How do we design the system? How do we implement the system? And the testing from each of these parts, the verification that the system works. And then on top, we have the validation that the actual business value or functionality is added. So what in the crossing model will happen is that we shrink this in time, because we are able to have a couple of steps that are automated, replicable, and generated based on our technology. So these two steps that were at the beginning very far away from each other, they actually collapse almost one next to the other. But well, that's a very good story, Santiago. How did you actually solve the how? Well, we have been working for the last over 4 years on this. So we did stand on top of this huge mountain. So I am a bit of a geological magician here, because I turn an iceberg into a mountain. But please follow me on the metaphor. And that's what happens when actually we have a software project that maybe we have an MVP, and then after MVP version, after our minimum valuable product, we want to go into production, right? Then we face this huge mountain of non-functional requirements. How do we secure? How do we have a change control implemented? How do we make it reliable? how do we, etc., etc. A lot of hows. So what helps us to navigate this this challenge and actually to climb this mountain at the end is to slice it into chunks that we will be able to understand. Luckily, we have a very good starting client. In this case, is actually ING, which help us to have a very clear view on what will be the whole banking requirement, non-functional world. So those can be mapped to process requirements, product requirements, and external requirements. And if we learn something from software engineering, is that to make something efficient, you actually need to shift left. So that's what we did from the very start of the project. We start shifting left all the risks. And what is a risk? There are unknowns. There are challenging processes that needs to be implemented in our technology. There are a set of elements that help us actually to transform these big chunks of work into very clear non-functionals: changeability, compliance, security, reliability. And with a team of very talented engineers, we managed to solve them using traditional building blocks in software engineering. So you have domain-specific languages, you have software generation, you have defense in depth, you have cloud nativeness, sec DevOps. So and each of these components, of course, have a lot of subcomponents attached to it. But the message here is that the challenge was sliced small enough to be able to use basically solutions that are already proven for years to work. And then the key of the success, I believe, is in that we managed to orchestrate them all together. So that's how we think about the elements in our technology. They need to be compliant, reliable, and secure, and of course they need to be resilient to change, because change is a reality not only from the users that are demanding, of course, new features, from competitors that are pushing new features to the market, but also in regulated environments is change from external parties like regulators, central authorities, etc. All of these blocks are actually very interesting, and I would love to talk about all of them, but we only have an hour for the whole meetup, so I will focus on security. That is also the one that is closest to my heart. So what about security? I'm going to start about the human part of security, and that's what we call layer 8. And in this case, is not the consumer part of the stack, but actually the developing part of the stack, and how this can have a tremendous influence on the speed that you get, and why it's actually a good idea to add security and cybersecurity knowledge in your team. So I'm going to start at a couple of decades ago when we used to have these two teams that was two actually different silos, two departments. They did not speak between each other. You have the developers, then you have a wall, and then you have the ops team, the operators, and you have some synergies there. That's how we thought about developing software at the beginning, but we knew that didn't work. So the syndrome, I develop, you run it, doesn't work, because they're actually part of the same. They are part of the same product. A developed software that doesn't run is not adding value, and you cannot run something that is not developed. So we figured out in the 2000s something that actually was a good idea to have DevOps together. So with the merge of these two disciplines, we broke the silos, right? So we said we develop, we run it, and if you are a bit more onto the technology part, is we develop, we deploy it, we run it. So the full ownership of the life cycle of the software will be in one team. And that is a bit, of course, intersecting with Agile, Scrum methodology, etc. But we thought that we managed to break the silos and to have a full end-to-end ownership of the product. And then we started realizing that we might have missed one silo. So you have seen this over and over again, news around cyber attacks, hacks, ransomware, etc. And this is just a post from the Daily Swing from, I believe, yesterday or 2 days ago about Vodafone being hacked. So something structurally is actually not working in the majority of this full ownership. So we are missing the security part. And just as we mentioned before, software that doesn't run is actually not adding value. Software that hacks doesn't add value as well. So when you develop a product, you want it to be not only functionally ready, but also performant, but also secure, right? You don't want your users to feel insecure when they use your product. So that's when we start questioning about the completeness of this full ownership team, and there is a couple of movements around this sec DevOps, of DevSecOps, of DevOpsSec. There is a lot of names around it, but basically the motto is we secure it, we develop, we run it, and you can think that we are actually moving back from the specialization that we have been tending towards to actually having super developers or super engineers that know a bit about it. Doesn't need to be like that. It's about having expertise in your team around these three disciplines, and of course you could say you could have more disciplines. Yes, you could, and depending on your area and your industry, that might be more relevant for you. For example, there is also FinOps, right? So how expensive is to run your product in the cloud, and these kind of other disciplines that are also intersecting into the creation and development of a product. But for now, the security part is actually vital. So there is no product that makes sense without security. But that, besides the fact that your customers will have a better security, your data will be secure, you will be able to run in a compliant way, for us led to very interesting dynamics. So, and looking at it from 2 steps back, whenever you have a new domain coming into in contact with another domain, you have this effect of cross-pollination. So basically, you start thinking together to solve a problem, and that's what we had in Crosslink. So from a very early on, we embed all these non-functionals in the definition of our software. And what started happening is that methodologies from the software development, from ops, from sec, start collaborating together, and that allows us to have vertical integration of security features. So you have a very well orchestrated security feature between the requirements engineering layer, that is when you define the product. So we are able to expose very cool features to these domain experts, from the architecture engineering, from the design to the implementation. So because we combine all these brains together with different backgrounds, we managed to have at the end a better product. Another very nice example is performance lookups over encrypted data that is normally a challenge in general for the industry. built-in security primitives in our domain-specific language. We managed to have these secure concepts in the language. So actually, someone that needs to secure, for example, personal identifiable information that needs to be encrypted, at rest, in transit, etc., we can allow that in a very simple way. So there is actually no development involved in making this happen when we generate software. And last but not least is the security awareness that your team gets becomes actually one of your core assets. Because then you suddenly stop relying in the testing that happens normally at the end of your chain. And that in the security side will be a penetration test, will be a hacking exercise, a white, gray, black hacking. Your development team becomes your first line and actually the one raising problems, potential vulnerabilities. And that's when you start thinking security in a purple way. That is a bit of how the industry call it right now. There is the mix between red and blue teaming. There is, well, the combination is purple. And when you think red and blue, there is basically when you embed the security into your development and operation teams is the multiplier that you get. So if we talk about people and how this helps us to secure our systems and the systems in general, we can move to defense in depth. And this will be your outer layer of protection. And defense in depth have actually several names. So you can call it defense in depth, layer security, onion security model. There are many ways to call it. It doesn't really matter. A lot of the security techniques that we have come from the military, come from tactics that have been used or are used in military exercise and how to protect, right? Because that's actually where humans learn to protect things that were valuable to them. And a very good representation of this layer security or defense in depth will be a castle that has multiple mechanisms of avoiding that the enemy comes in. And what will sit inside a castle is, in this case, the royal family. It will be basically the people living there. It will be basically what is valuable for this castle owner to protect. And you will have water around the castle, a bridge that can be lifted, very strong walls. Inside the walls, you have inner walls. You have towers from where you can observe, etc. So you can make the match to how we understand security and how we understood also security before. Perimeter security, zero trust, all this comes to what are actually the strength of your defense system, right? I chose this particular model on the defense in depth, and there are actually many ways to call each of the layers. It really depends on the kind of threat modeling you're doing, the kind of asset you're protecting. But at the end, the name of the layers doesn't really matter. What is important is that this is a tool to think about how secure is your system. And how secure is the system is when you think about connected elements in series, your system will be as strong as your weakest link, right? But in this case, we have actually a different mental model. We have a layered model. So your system becomes as strong as the weakest, most exterior layer. So that means that the outer layer that is the weakest will be always the entry point. So if you think about this castle metaphor, to walk in the castle, you will need to pass all these barriers. So you will need to compromise each of these controls to make it to, for example, the treasure or the gold that is being protected by this castle. So what we tend to forget is that actually most of the things that we are in contact with these days are made with software, right? Even hardware, the hardware world is moving towards software, with software-defined networks, with chips that are able to actually be modified at the software layer. So we're moving on the abstraction layer up, and we forget that these abstractions, these security abstractions, are based in software, and the software fails, right? So having said that, moving back to the perimeter security model, where you only have a very strong castle wall, that make it weak in the sense that if at any point any of these segments of this castle wall breaks, your whole system will be compromised. So in this layer security, it's very important thing that each of the layers has a probability of failure, right? And what you actually want to minimize is the aggregated probability that all of the failures, that the layers fail in a dependent way with the layer above. So you will never like to have a situation where your perimeter security is actually, for example, linked one-to-one to your internal network security, because a defect on one of them might lead to the defect in both. And a very good reminder to this is the Chinese wall. So the Chinese wall was a wonderful piece of engineering that actually kept people from invading mainland China from a lot of years, until a couple of the processes that were in place start failing, and then this powerful warrior Genghis Khan was able to cross in and out the wall, because the processes that were supposed to be attached to this very strong external perimeter wall were failing. So at the end, whenever you have a failure in a very strong layer, it doesn't really matter. It's also a failure, and software will fail. That's why this nice pop-up from Windows is there. Software fails in very weird ways. So in this case, think about this also as a software component. That if you slide back a couple of slides ago, you can think it is in the SecDevOps approach. This control needs to be tested often, right? Just as you think it about any other piece of software, you need to test often, validate, and try to bring the distance, to have a distance as short as possible between the creation of the control and the validation. That is what we saw when we compress the V into with this automation, code generation, etc. The human layer is actually it can be your best friend and your worst enemy. So invest in that. Policies, procedures, and technology that are human friendly will actually make the difference between a secure and an insecure system. A very good example is all these password policies that we have, that they need to change every 15 days. They need to be combinations of 20 characters. They cannot be characters that are repeated more than once, etc. So if your security policy becomes so complex that no human can remember it, then the policy lost its effectivity, right? So always keeping the human part in mind and usability in mind will help you to build a very strong outer layer. And finally, on perimeter security is what we have been trying to work away from as an industry. A new, stronger outer layer doesn't give you more security, right? It's putting all your eggs in the same basket. And when you have not 100% reliability in this layer, it's not a situation you want to be. So investment along the chain of layers is yielding way better results than a very strong outer layer. All right. So we went through a lot of things, and besides you knowing more about what Crosslink does, I wanted to summarize a bit of the key learnings that at least we had to make all this non-functional journey work for us instead of against us. And the first one is shift left, abstract, and automate. So there is this very powerful saying, go slow to move faster. And that is what we did at the beginning. We took our time to analyze, to think through, to cross-check with our multiple disciplines how we could embed all these non-functionals and do the heavy lifting only once. And that is really going to make the difference in any project that you do. It's independently of which technology you use. The functional part is not the whole story, so don't be agnostic to really what is underneath and plan for it. And finally, for everyone approaching security or thinking security or trying to bring security expertise in their team, don't forget this is also software based, right? And software fails. And you need to have, just as you have for your other software systems, resilience, backups, and a well-thought strategy on what will happen when your software fails. And that will be it. So I hope you learn a couple of things. I actually would like to go to the Q&A, and I will make a second piece of advertisement. We are hiring, so if you go to the QR in the left, you will see the positions we have open in the ING portal. We are looking for engineers in all of our team. That is the front-end team, the back-end team, the SRE team, and the business engineering team. We are trying to grow the team to make our vision happen. And if you have any other question, if you have questions you don't want to necessarily express here, you can always reach me out in LinkedIn. The link is also there. Thanks for your attention.
Thank you, Santiago. It was great that you share your knowledge, and I love the metaphors you used. We already have one question in the chat, and Harry Veenstra is asking if this is suitable for banking processes only.
That is actually a good question. The short answer is no, and the long answer is also no. So we are an initiative of ING Neo, right? So we are building a product. We have been building a product, and this product building needs focus. Where the point where we started, or the point where the founder of Crosslink started, is more than banking. if you think about it, and if you are thinking about, okay, all these constructs actually could make sense in other domains. Yes, that's the right conclusion. For us now is focus. If you have an interesting use case in an environment where the non-functional part is actually challenging, please let me know. So we are very happy to have a discussion about it. But at least in the midterm, where makes sense to apply these techniques, because it's a lot of engineering, a lot of effort put into the non-functional automation, is on environments that are drawn by these requirements, right? So if you will have the situation that you want single page application, I will not recommend you to use this technology to use it. But for example, healthcare, other industries that are heavily regulated are also very good candidates for this. You're in mute, Mariska.
Thank you. I think it's a clear answer. If Harry has another question, please let me know. But also Herman Kemper wants to ask something. Can you unmute your microphone, Herman?
Yes, I can. Thank you.
Thank you.
First of all, thank you, Santiago, for your clear presentation. I really liked it. What I see within ING, that the focus is on creating business value by the DevOps engineers, and non-financial risk requirements are often seen as not to be part of creating business value. What is your idea and advice to tackle that?
Yeah, that's a very good question indeed. I would say that the answer is close to what I was describing with the move from DevOps to SecDevOps. So an application that doesn't satisfy non-financial risk requirements, if you are in an environment that, for example, ING requires this to operate, you cannot count that you are actually adding the business value, right? Because you have a couple of checks in the box that you are not complying with, and then your business value is not materialized because of that. On the other side, I understand that the non-functional requirements that are around this non-financial risk part are very sneaky if you don't know how to gather them and tackle them. So what it helps us in our journey is bringing all this risk left, and that also meant going and sitting with experts in non-financial risk and saying, okay, you have these policies, minimum standards, and controls. What do you actually mean? And that helped tremendously to not only get their mindset in our way of working, but also in really solving their concerns, because at the end, these non-financial risk requirements are trying to keep these applications secure and compliant. And for me, at least how I think about compliance is a very well executed security strategy and a IT processes strategy, right? So if you have this right, you will be compliant by default. But to have this right, you need to go to this other domain that is non-financial risk, put your brain together and say, okay, I am an engineer, you're a risk officer. How do we get this working in the way that we both want? And it takes effort at the beginning, but if you make it part of your journey and have very clear touch points with them, that's something that will speed up your journey at the end.
Okay, thank you. I have another question from Peter. Hello, Peter. Most of the time, security has to be built in afterwards, leading to higher costs to implement countermeasures, security by patch.
Yeah, exactly. Yes, that's the what that's just reacting to what Santiago says. Indeed, if you if into the question of also before, if you do it afterwards, yes, then it will become security by patch, and that's countermeasures will become more expensive and many times even less effective. So yes, security by design is very important. I fully agree.
And maybe Peter, to add on that, if you come from the security world, there is this very famous certification called CISSP. I was very surprised when I went to some lectures of these people trying to share the mindset, right? And their mindset was, and it's quite interesting. I don't necessarily share it fully, but it's security is actually in charge of keeping the business running. That's a bit of a overscope of security. But how I understand it and how I adopt that part is that if you think that actually a feature doesn't make sense without being used, that automatically should bring you to the user should feel safe in what they are doing, right? And then that's where you say the security needs to be shift left, right? And maybe here is something that is as a general industry, security should be part of technology rather than from operations that happens in a lot of companies, or maybe security should be a vertical thing, or maybe security, as SecDevOps proposed, should be actually knowledge that is in all of the teams.
Yeah, indeed. Well, I've done the long time ago. I've done the exam, the CISSP. But for me, it was just something to do besides the other work. But I found out that once you get into the security, that is it's almost a full-time job. It is like we have some confluence. Okay, well, making the authorization in order, arranging pen tests, all that kind of things. Yes, it's almost a job in itself. It's really, yeah, it's a lot of you can spend a lot of time on it. A lot of time on it. But the exam, I liked the exam because it was it's very complete. It goes through fire extinguishers and watchdogs. So literally, so this is a very, yeah, but it's a complete overview.
It's a really good overview. That's true.
Okay, I don't see other questions anymore. So Santiago, thank you. We recorded it also, and we will share it on our ING YouTube. So for now, I will thank you all, and yeah, see you in the next meetup maybe, and that's already in March the 3rd. So see you then. Bye bye.
Thanks for the attention, and thanks, Mariska, for organizing.